Okay, in this video, you will learn about significant figures and how many significant figures to report when you're measuring an object, and also when you are carrying out calculations. Okay, so how do scientists know how many digits they will record when you write a number down? This is very important in the lab because you will be the one measuring masses, volumes, lengths, and you need to know how many digits you will write. So let's take, for example, here we have a balance, and if you look closely, you can see that this balance reads to the tens place in grams. So if we had an object, let's just say it was 5 grams, you would write 2 digits, right? 5.0. But if you were using this more expensive balance over on this side, this is called an analytical balance. And this is what you would find in the chemistry laboratory. You can see that it goes all the way to the 10,000th place. And so if you were reading that same 5 grams, you might get something like 5.0272 grams. You can now read more places to the right of the decimal. And this, because you can read more places, you can see that this extra mass over here, right, is undetectable in the cheaper balance, right? So you are missing some mass that the more expensive balance can pick up. And so you're more likely to get accurate and precise measurements. Okay, so these are both measured numbers. Let's say you're in a microbiology class and you were told to count the bacterial colonies on your petri dish, and you would just simply count them. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You would write that you have 10 colonies. Okay, and this, though, is an exact number, because we are counting objects. It does not depend upon our measuring device. So if we look over here on this measuring balance, this measuring tool, this balance, we can only write 2 digits. But over here on the more expensive balance, we can write 5 digits. These are your significant figures. How many should you be writing down, right? And over here, since we're just counting, right, that's an exact number. We say here there are no significant figures for this, right? So no, we just abbreviate sig figs SF, no sig figs. Okay, so exact versus measured numbers. So just like we talked about, exact numbers are counted numbers or have defined values. So like counting money, right, that's an exact number. Counting eggs, 1, 2, 3, 4, 5, 6, 7, right, you can say 7 eggs. Right, this is exact. Right, we don't need to worry about significant figures for these. And also when you're in a math class, in general, you don't need to worry so much about significant figures because they're not working with measured numbers. But when you are, then you should be aware of the significant figures. And over here with the ruler, right, this is a measured number. Okay. We're reading the length with a ruler, right, in centimeters. So you would have to read right here, and maybe that's about 5.21 centimeters. So I know, based upon my measuring tool, how many significant figures I can write. And also, when you're reading measurements like peaks on a graph, you also have to look at your scale on the side, on your y-axis, right, your graduations. So if we look at the first graph, these are the same graphs, just one has more graduations than the other. I could say I know that the first digit is a 1, because I know this goes from 10 to 20. So my first digit in the tens place is a 1, and I'm going to have to estimate that ones place. And I'm going to estimate that as an 8. Okay, now if you have more graduations, and let's zoom in over here, you can see here's 20, and this is 18, and I have a little bit more over 18, so I know 18 for sure, and I'm going to have to estimate that last one, maybe a 2 or a 3. Okay. And so in these examples, these are both measured. I would record 2 digits on the first graph, and I would record 3 digits on the second graph. So again, it depends upon your measuring tool. Okay, so what exactly are significant figures? They're the meaningful digits in a measured or calculated quantity. You're going to write down all measurable digits, plus you're going to estimate between your graduations. So it's the ones you know for sure, and then one more that's estimated. Okay, so let's read this. Looks like a burette, and we're reading a volume. And when you read a volume, you're going to read at the very bottom here, and that is called the meniscus. So we're going to read right there at the bottom of the meniscus. So first you want to be sure you understand the graduations of your measuring tool. And I see here that it starts at 6. Okay. And the next one, I can see there's a difference. This line is a little bit longer. So that's probably 7, and then this goes to 8. So it looks like each mark is going by 0.2. So 6.2, 6.4, 6.6. Okay, let me just erase that line there. Oops. So I would pick about 6.62, right, as my final measurement. Oh, I don't know what just happened there. Sorry about that. I guess I got to start that over. Okay, that was interesting. Okay, so since I can see that on this last graduation, I know 6.6 for sure, right? Those are my measurable digits. And then I'm going to estimate one more, and I can see it's a little bit above that line, right? So I'm going to estimate a 2. Now, if you estimate 6.63, that's fine, or 6.61, that's okay too, because that last digit is estimated by you. Okay, and remember that significant figures, right, depend upon, right, the measuring tool. So on, like if we go back to our example at the beginning, remember this balance is only going to give us to the tens place. So if we were measuring something like the 5 grams, remember it would only give us 2 significant figures. And I believe we wrote 5.272 grams. And I would say that that was 5 significant figures. So 2 sig figs this balance and 5 sig figs for a better balance. So your significant figures depend upon the tool that you are using. Okay, let's try a few more. And feel free to pause the video, right, and figure out your answers before I go over them. Okay, so looking at this one, it looks like we're measuring, it says, what is the length of this red line? It's going from 8 to 9. We're in centimeters. So I know this is 8.5, 8.6, 8.7, 8.8. Okay, so I know 8.8 for sure. And then I need to estimate one more. And I can see that this red line is definitely beyond half. So 8.85, it's past that. And I'm going to estimate 8.87 centimeters. And so that red line has 3 sig figs. What is the temperature in this measured by this thermometer? Okay. So again, you would kind of get your bearings. You see this is 20, that goes to 30. So each graduation is 1 degree. We're reading in Celsius. Okay, so I would say 20, 21, 22, 23, 24. So I know 24 for sure. And between 24 and 25, it's not quite half. So I would say 24.4 degrees Celsius. And that answer also, right, has 3 sig figs. Okay. And so when you're in the lab, and I know which instruments you're using, that I am looking for the correct number of significant figures. But even if you didn't actually make a measurement, when you're doing problems in the textbook, you need to be able to determine the number of sig figs, right? In a number, in your calculations, and there are some rules to follow. So let's go over the rules. They're not too difficult. All right, so we have first rule saying that all non-zero numbers in a measured number are significant. Okay, so looking at these measurements, 38.15 centimeters. Well, they're all non-zero numbers, so they're all significant. So there are 4 significant figures. We have 5.6 feet. That's 2 significant figures. And 65.6 pounds, 3 significant figures. Okay, they're non-zero numbers, right? So they're all significant. Okay, that one wasn't too bad. Okay, now the leading zeros. Okay, these precede non-zero digits in a decimal number, and these are not significant. They're kind of just like placeholders to give you the magnitude of the measurement. Okay, so if we're looking here, we have a 0.008. These are all leading zeros. And so 8 is the only significant digit there. And so we'll say there's only 1 significant figure. Here we have 0.0156 ounces. These are not significant, so 3 significant figures. And again, the leading zeros are not significant, so 2 significant figures. Okay, the trailing zeros. And this is the one missed most often. So for trailing zeros that follow non-zero numbers, right, digits, are significant in numbers that have decimal points, okay, but are not significant if you don't have a decimal point. Okay, so let's look at these numbers here. So we have 25.000 grams. So instead of just writing 25 grams, they made a point, right, to put those zeros there because they are important. They're telling you that they can read all the way out to the thousandths place. And so they are significant. They're telling you how good that measurement is. So that's all 5 of them. Okay. So if the trailing zeros follow a non-zero number and there's a decimal point, they are significant. 20.0 kilograms, all significant. Now we have 48,600 milliliters. Okay, this number does not have a decimal point. And so I'm not sure, right, if those were actually measured or not. Because if they wanted to make sure that I knew those were measured, then they would have a decimal point. But we don't see that. And so only the 3, right, are significant there. How do I get? Yeah, let's erase that. All right, and then sandwich zeros. If you have zeros between non-zero numbers, right there, they are significant, right in the middle of the number. Okay, so 50.8 millimeters, all of them are significant. 2001 minutes, all are significant. Okay, now this one is 0.0702 pounds. Remember, these are not significant, but the sandwich zero is significant. So that's 3 for the, what just happened? That's, sorry about that. We went through these. Okay, so 3 significant figures for the 702. And then the last rule here, if you're talking about significant figures in scientific notation, you only look at the coefficient to determine how many are significant. So in the first number, we're just looking at the 8 only. And so that's one significant figure. 8.0 would show 2, and 8.00, that is 3. So significant figures of the coefficient only. Just let's do a few practice problems here. State the number of significant figures in each of the following measurements. Okay, so we have A, 0.030 meters. We have leading zeros and a trailing zero. We have the decimal, so the trailing zero is significant. So this would be 2 significant figures for the 3 and the 0. Okay, B is 4.050. We have a sandwich zero and a trailing zero with a decimal. So all of them count there for significant figures. And then on C, we have 0.0008 grams. Those are all leading zeros. They are not significant, so 1 significant figure. All right. When you are writing numbers from your calculator, so when you are calculating answers, you oftentimes get many, many digits, right? You see a whole bunch that your calculator will, calculate for you, but you don't want to write all those digits, right? You need to know how many digits you should be reporting, and that there are rules for that as well. So how many significant figures can you report depending on the numbers in your problem? Okay, so when you see an answer like this in your calculator, you are most certainly going to be rounding off. So we follow the normal rounding rules you've learned. And so if you have the next number being a 5 or higher, you would round up, and if it's a 4 or lower, you round down. And so in this problem, it says adjust the following calculated answers to give answers with 3 significant figures. So you are only allowed, or you should be writing 3 significant figures for your answer. So here's our 3 digits. That's 8, 2, and 4. The next number is a 7. So this would be rounded to 825 centimeters. The next number is 0.112. Those are the digits that we're keeping. We look to the next number, it's a 4. So we will be keeping it as is. So that's 0.112 grams. So those have both been rounded to 3 significant figures. All right, what are the rules for when you're carrying out calculations? Okay, rule number 1, and this is for multiplication and division only, and it's actually the easier rule, that you cannot have more significant figures than either of your original numbers. So if we look at this, we're calculating miles per gallon, and so it's a division problem. we have 278 miles. That's 3 significant figures. And that was 11.70 gallons. That's 4 significant figures. Your answer has to come out with the least precise significant figure. So it cannot have more significant figures than either of your 2 original numbers. So 3 is lower, so 3 is what will be reported. So give an answer for the following with the correct number of significant figures. Okay, so we are carrying out multiplication. There's no units here, but let's assume these are measured numbers. And we don't even need to calculate it because the answers are all very similar. And we're just looking for the significant figure. So here, this one has 3 significant figures. Let's write that in. We have 3 sig figs on that one. And this number here has 2 sig figs. And so our answer has to match the least precise original number. So that would be 2 significant figures. All right, let's take a look at B. This is a division. This number has 4 significant figures. And this number right there only has 1 significant figure. So our answer can only have 1 significant figure. So that would be this one. So remember that 0 is not significant on the 60 because we do not have a decimal. All right, rule number 2, this one is for addition and subtraction. And your answer cannot have more digits after the decimal point than either of your original numbers, or more digits after the leftmost certain digit found in either of your original numbers. Okay. Sounds complicated. It's a little harder to remember, but let's go over why this is so. Okay, so let's take a look. Here we're adding 2 numbers, 3.81 liters to 0.01315 liters. Okay, so when you add these together, you're now more concerned about the placeholder, right? Is it the tens place, the hundreds place, the thousands place, or on the other side, right? We're looking at the tens, the hundreds, the thousands. Oh, that should. Okay, so when you're adding, remember these places in this first number, right, are not certain. We don't know what they are. So you really cannot write a number there, even though you have numbers in one of your original numbers. So because we're saying that they're uncertain, we can't record them. So we look, so the ones place, the tens place, the hundreds place, they all have digits, but now the thousands place, we don't know what this one is, so we cannot report it. Okay, so you're looking to the places to the right of the decimal. Okay, so in summary, if you look at this first number here, we would say there's 2 digits to the right of the decimal. And over here, there's quite a few, 1, 2, 3, 4, 5, 5 to the right of the decimal. We're going to go with your least precise answer and only have 2 digits to the right of the decimal. Oops, how do I go? Sorry about that. Let's see. Okay, now let's take a look at this example down below. And again, we're looking at the placeholders. So we see here that we don't know what's in the ones place, right, for either of those numbers. And in this one, we don't know what's in the tens place. So we can't report in the tens place. We do have a number in a hundreds place and the thousands place. So those can be reported. Okay, so your answer would come out to be 3,200. And we cannot put a number in either the tens place or the ones place. So let's try this out. Okay, so for each calculation, round the answer to give the correct number of significant figures. So we're adding 3 numbers together. This one, and this one. Now we're not looking at how many significant figures each number has. What we're looking at are the places to the right of this decimal. So we see this one has 2 places, this one has 1, this one has none. And so I can only report an answer that matches the least precise of those numbers, and that would be this one. Okay, just stopping at the ones place. Okay, now let's take a look at the second problem. Yeah, 58,000 minus 1,880. And again, I see that we have the number here in the 10,000s place, the thousands place, but not here in the hundreds place. So I'm going to have to stop my answer in the thousands place. And so that one would be this one. So this, you will get more practice with this in the laboratory and in your homework.